Okay, let's take a look at polynomial functions, and of course we are going to take a look at their graph. Before we can see those functions, let's see what is the definition of polynomial function. So sure enough, if you see, it must be a function. Function is the relation that each input corresponding exactly one output. So what is the definition of that? Any function in the form of f of x is equal to an xn plus an minus 1 xn minus 1 plus all the way to a1x plus a none. So in here you can see those exponent n is a non-negative integer. Integer, and then those notation an minus 1 all the way to a1 a none, they are coefficient and they are real numbers. So in this case we set the an not equal to 0. Indeed, an we call that is leading coefficient. So the highest degree in here is n, so we call this as polynomial. F is a polynomial function of degree n. Alright, with that we can take a look at the graph. So some of the character of the graph I want to mention before we move on. One is called smooth. Okay. So right now we don't take a look at the really official mathematical definition of smooth. Just think about in our real life, what is smooth? It's the same idea in here. So smooth, that means the graph contains only rounded curve with no sharp corner. And also the graph of polynomial function is continuous. Continuous, just like you're using a pencil to draw some graph, and without lifting your pencil you can complete it, the whole piece. So that's called continuous functions. So no break. And as I mentioned, can be drawn without lifting the pencil from the coordinate. Where right now we are only using rectangular coordinate, right? For the rectangular coordinate. Okay. So the first thing, let's see. Well, we wanted to see how the graph looks like. And the first thing we want to see the graph is the n behavior, which is mean the overall behavior. Okay, n means toward to the both end from your x-axis. So for the n behavior, we are going to use leading coefficient test. So from here we are going to take a look what happens as x approaches. So we use this notation, infinity and x approaching to negative infinity. So the n behavior is determined by the term with the highest degree. Or highest power of the input x. So the one thing. Another thing also is determined by the sign of the leading coefficient. And later on, I'm going to use LC to represent leading coefficient. So in order to do this, we are going to use a test called the leading coefficient test. So in this test, it says that as x increases or decreases without bound, which is the one we mentioned, approaching to positive infinity or negative infinity, and the graph of these polynomial functions f of x is equal to an xn plus all the way to a1x plus a none, with an not equal to 0, eventually raises or falls. So how the raise, how the falls go. And let's recall something before I give you the fact. Recall. If we think about the linear functions we learned in the past several sections, y equal x, right? So you have this side, left side falls, right side raise. And if you have y equal negative x, this is slope is negative, so that's y, that's x. Then your left side is rise, and right side is falls. Also, when we learn the cubic functions from the parent functions, it looks like this. So your right side raise up, and left side falls. From the quadratic function we learned, when you have a quadratic functions with the leading coefficient is positive, we say the parabola open upward. For instance, this is y equal to x squared, right? Both sides raises up. And when you have the coefficient is negative, for instance, negative x squared, then the parabola is facing down, and that is y equal to negative x squared, right? But the both are fourth. So what I meant in here is you can see math is just pattern. You see this, you have the exponent, they are odd number, and then the opposite side, their behavior differently. When you have the exponent is even number, the opposite side and behavior behave the same. So that will give us the fact that when the n, the degree is even, okay, so depend on your leading coefficient. If your leading coefficient is greater than 0, just like this, then your both n is raises up. Okay, so in between we have something need to fill up. Along the courses we are going to learn different information. For instance, how many turning points, and what's the intercept, and what's the y-intercept, etc. When you have the leading coefficient is negative, just like this one. Okay, so the both sides that will fall. Okay, again, in between we have some detail to fill up. But in here we only talk about the n behavior. Alright, so when you have the degree is odd, then an is greater than 0. The leading coefficient is greater than 0, just like the linear functions or cubic function is greater than 0 leading coefficient. Your left side falls, right side rise. So left side falls, right side rise up. So in between, again, we need to do some more work for fill up the information in between. When the an is less than 0, the leading coefficient less than 0, then right side falls, left side rise. So in between, I need to get some more information of that. Alright, so those are n behavior. Let's take a look at a very quick example for the n behavior. we are going to determine the end behavior of maybe g of x is equal to negative x4 plus 4x cubed minus 4x squared. So you can see that the degree n in here is 4, which is even. And the leading coefficient is negative 1, which is less than 0. So by the leading coefficient test, even, negative leading coefficient, therefore the end behavior is both sides 4. So you have 4 on this side and 4 on the right side as well. So in between, we are going to fill out the information. So one of the things in between the information is y-intercept. It's the same way as finding y-intercept as the other function, but I wanted to mention the x-intercept. Before we talk about x-intercept, let's understand what the 0 means. So what the 0 means is the value of x where your output, which is f of x, equal to 0. So that's called 0. And sometimes we call that is the root, and is the solution of the equation f of x equals 0. So what's the x-intercept? How the x-intercept related to that? Recall that on the xy plane, all the values are real numbers. So therefore, when you have the real 0, which is a 0 of real numbers, they are the x-intercept. So keep that in your mind in here. Not or, excuse my pen, it does not come out. So we say that not all zeros are real. Okay? So one of the facts we know that is for the polynomial functions. We say that a polynomial function of degree n has at most n x-intercept. So it's at most, which is the real 0. Let's take a look at some example. Find all the zeros of f of x equal to x cubed plus 4x squared minus 3x minus 12. To find the 0, then we say that, okay, is the output equal 0, therefore so f of x equals 0. F of x equals 0, that's the same as x cubed plus 4x squared minus 3x minus 12 equals 0. This is 4-term polynomial. The way we show that, we need to factor, well, 4-term we are going to use grouping method. Usually we group the first two and group the second two, the last two, to see what we can get from there. Alright, so that is x cubed plus 4x squared, and these two together, so that will be plus negative 3x minus 12 equals 0. Compare these two, what's the common factors? Greatest common factors, x squared. So we are going to factor x squared. So we have x plus 4. And this one, we can factor the coefficient of x with negative 3. So minus 3 x4 plus 4 equals 0. Between these two terms, you have x plus 4 are common factors. So that's x plus 4 times x squared minus 3 equal 0. The reason we want to factor that is we can apply the zero factor property. Which is, if we have a product equal to 0, that means one of the factor must be 0. So either x plus 4 equals 0 or x squared minus 3 equals 0. So from the x plus 4 equals 0, subtract 4 from both sides, you have x equal to negative 4. For this one, you add both sides by 3, so x squared equals 3. So x squared will be plus or minus square root 3. That's applying the square root principle. Right. So with that, we can conclude that the zeros are negative 4, positive or negative square root 3. Right, let's take a look at another example, which is the one we saw the end behavior from the last example. Okay, g of x is equal to negative x4 plus 4x cubed minus 4x squared. Similar idea. First thing, we are going to factor out the GCF. In this case, the GCF is negative x squared. So negative x squared, so that's x squared minus 4x plus 4. Continue factoring. So this is a perfect square, right? So because 2 squared, then twice 2 is 4. So that will be negative x squared, x minus 2 squared. But in order to solve that, the reason I wanted 4 factor out is because we need to find the 0 by starting g of x equals 0, which is in this case is negative x squared, x minus 2 squared is equal 0. If your product equals 0, maybe one of the factor equals 0, either x squared equals 0 or x minus 2 squared equals 0. In order to have this one equals 0, you square root from both sides. Well, 0 does not have sides, so still equals 0. And this one you get x minus 2 equals 0, so x equal to 2. So you will have 2 zeros in here. The zeros are 0 and 2. So that is the 0. Well, and you might see that some of the 0, for instance, this 0 coming from x squared, and this 2 coming from x minus 2 squared. But this one is negative 4 is coming from x plus 4, right? So they have different power. That's related to the multiplicity of the 0. Let's see. So sometimes you see sometimes your function you have x-intercept, which is crossing in here. For instance, this is r, right, crossing in here, and this is function f of x. Then you can see f of r is equal to 0. So r is a 0. So this is cross. And also you will have, sometimes you have something turn around like this. If you are right here, f of x, okay, and this is x-axis, and this one also your f of r is equal to 0, but your f is touches at x equal to r right here. So how can I know when it's cross, when it touches? So that will related to our multiplicity. Right. So when the multiplicity is even, oh, my mistake. When the multiplicity is odd, because I have the odd first, so you will have cross. And when you have the even multiplicity, that will be touching. Well, that's coming back. Okay, then what is really is the multiplicity? If I have a function, f is a polynomial. If I can factor that completely, it looks like an times x minus r to k power times x minus maybe h to the over those power, right? Maybe m power. Okay, so those are 0. So for instance, this one is r is a 0 with the k power, that's the multiplicity, with multiplicity k. So you can see that well, before I move on to the example, I wanted to give you another fact that's very important, that if your graph tends to flatter out near the 0 with multiplicity greater than 1. Okay. Alright, let's go back to see our example. Let's record the example. G of x is equal to negative x4 plus 4x cubed minus 4x squared, right? From here, we do get that it's negative x squared, x minus 2 squared, right? So you can see x equals 0 is a 0 with multiplicity is 2. Okay, so 0 is a 0 of multiplicity 2 because it's even, right? And x equal to 2, the square, also 2 is a 0 of multiplicity 2. Okay, well, so let's take a look at another important theorem before we can move on to more information of the graph of polynomial functions. The next theorem is the intermediate value theorem. Okay, to save time, I have the theorem written on the paper already. So we say let f be a polynomial functions with the real coefficients if f of a and f of b have opposite sign. Okay, what it meant in here is you have x. Remember, the graph of a polynomial function is smooth and continuous. So if you f of a, maybe a is right here, and f of a is negative, and b maybe right here, f of b is positive. They have opposite sign. So you say that then there at least exists one value c between a and b, then the value f of c equals 0. That means if I have a graph of polynomial function, it must intersect x-axis at least once. Okay, so that is your c. That's at least one. Or maybe sometimes, the reason we say at least is maybe your graph might look like this. That's possible too. So in this case, you have 3 zeros in here. Right? So that's what the at least means. So which means that f of x equals 0 must have one of the root in between a and b. So this theorem really did not solve any problem, but that gives us an idea. If you have two values, one is negative, one is positive, maybe this way as well, there must be a 0 in between. So when you solve your problem, you know that you have a number in between them, a and b. If we take a look at this graph, and also this graph have some turning point. So turning point is another thing we want to talk about in this course. In pre-cal 1, we only can learn about maybe maximum how many turning point you can have in a graph, and exactly where it is, we won't be able to solve it until you get into Cal 1 course when we learn about the derivative. Okay, so that is our turning point. So a polynomial of degree n, okay, this graph has at most n minus 1 turning point. So with all those information, I guess we can take a look of some graph. We can graph that completely. Okay, so let's take a look of the g of x we talked about at the beginning of this lecture. Okay, we are going to put them together. G of x is equal to negative x4 plus 4x cubed minus 4x squared. I'm going to put those information together. Remember, the first thing we are talking about is end behavior. Okay, so we are going to use the leading coefficient test. For the first example, we know the end behavior is because it's even degree, both point to the same directions, and since the leading coefficient negative, then it's both pointed down. Right here, that's the end behavior. I just noticed that it's a little bit dark in here. Let me adjust the lighting of the. Okay, hopefully it's better. And also we talk about the x-intercept. And their multiplicity. Right. So we recall that how to find the x-intercept. You set this guy equals 0, which is we got negative x4 plus 4x cubed minus 4x squared equals 0. And I'm going to speed out a little bit because we did this problem in the last example. So in here, we say that you set x squared equals 0, and you found x equals 0. So that one 0 has multiplicity 2, which is even. So even, that means your graph, if this is 0, maybe touches, go around this way, this is x-axis, or maybe touches from above, right? So that's what the x equals 0 meant. The other one is x minus 2 squared is equal 0. So from here we got x equal 2, and this one 2 has multiplicity of also 2 is even. And when it's even, it touches again, similar to above. And I'm going to add some more information. When we talk about graph in the quadratic functions or linear function, we also talk about the y-intercept. So of course we are going to have the y-intercept information in any polynomial function as well. The way we find y-intercept is letting your input equal 0. Right? So basically we are looking for g of 0 that's equal to negative 0,4 plus 4 times 0 cubed minus 4 times 0 squared. In this case, y-intercept located at 0. Another one we are going to talk about, we did that, the symmetry, right? The even and odd function. And in here we are going to take a look at the symmetry as well. Remember the symmetry is the symmetry with respect to y-axis, which is the y-axis symmetric is for the even function. What the even function is, you have f of negative x that must be equal to f of x. And also we have the origin symmetric, that is the arc function, which is f of negative x will be negative f of x. So no matter which way, we need to test the f of negative x, right? So in this case, we are having g of x. So let's see. G of negative x, that's equal to negative x4 plus 4 times negative x cubed minus 4 times negative x squared. So that's equal to negative x4 plus negative 4x cubed minus 4x squared. So it's negative x4 minus 4x cubed minus 4x squared. Let's compare with g of x. We know g of x is negative x4 plus 4x cubed minus 4x squared. Well, they're not the same. So in conclusion, that's not even. So the graph won't be symmetric about y-axis. And let's compare with negative g of x. That is negative x4 plus 4x cubed minus 4x squared. Distribute negative inside x4 minus 4x cubed plus 4x squared. Well, they don't look alike either, so it's not the same as negative g of x, so that's not arced. That means the graph is not symmetric about origin either. And also, we wanted to take a look at the maximum turning point. Right? Which we say maximum you have m minus 1, turning point is 4 minus 1. Maximum have 3 turning points. Okay, with this, I'm going to put all those information together and to graph these functions. Your x-axis, y-axis. And in the graph, we see the m behavior both point down. I have that in my mind. And the x-intercept, I have one is 0, okay, and one is located at 2. They both bounce back. So that's another one right here. And what else I know? Maximum turning point 3, not symmetric. But if you need more for the graph, you can use plot more points to help you to get the graph idea. Or I can just using this m behavior. Remember this part is m behavior is going down. Right, so from the left to right is smooth, continue. I need to draw the graph up until I get into the intercept. In this one, we say that is touches, right? So we go back. So in this case, we know that it has to touch low and turn around. Okay, somewhere I need to turn around to touch this point, right? In this pre-calc 1 class, we don't have enough knowledge to see where it turns. So that's the reason we can just turn anywhere as soon as you turn it. And remember, this one is bounce back as well. So bounce back, and the m behavior is pointed down. Here we go. So that is the graph of this polynomial function. All right. Hopefully that can give you some idea how to plot the polynomial functions. And I'm coming back to this again. So several things you need to analysis when you graph a polynomial function. First, we are going to take a look at the m behavior by using the leading coefficient test. And then you need to see in between what happened in here. So in between what happened here is the step 2 to step 6. Okay, all those steps is not necessarily be in order. As long as you cover all those, you will be fine. So we need to take a look at the x-intercept and their multiplicity, because the multiplicity can help us to see if the graphs are turned around or cross the x-axis. Also, we need to take a look at the y-intercept and using the symmetry to help us to graph in case they have some symmetry. If I have symmetry, I can draw one part of the graph and then draw the other part symmetry to it. And also take a look at the maximum turning point. If you still have no idea what the graph looks like, just get some more points, satisfy the equation, and with that, putting all this information together, make sure the graph is continuous and also smooth, and you get some polynomial functions graph. Okay, so I think that will be it for this lecture, and I will also post more example other than this video to show you how to graph polynomial functions. Thank you.